I'm Warren Oliver. I'm president of Nanomechanics Inc. and we produce a product called inSEM, which is used to make the mechanical properties measurements of really small volumes and thin films inside an SEM or a focused ion beam FIB system. The idea being that a lot of materials are sensitive to the environment or react with the environment, or there are situations where we actually want to make the specimen using the focused ion beam capabilities or characterize the material in some other ways using other tools inside the focused ion beam. And then we want to do mechanical testing on those same samples. We might do a bend test or an indentation test or a compression test. These are all different kinds of mechanical tests that we can use to characterize the strength and properties of materials. Turns out that thin films appear everywhere in our life, and in many situations it's difficult to measure the mechanical properties of those materials in the atmosphere. So we have to put these materials into a vacuum to protect them as we test them. And then we have the additional benefit inside the SEM or FIB where we can watch what actually occurs in these microscopic experiments using the microscope as the test actually goes forward. So the inSEM product line that we have is a set of modular components that can be combined in a number of different ways to produce an experimental setup that is situated to do the best job of measuring what you're trying to measure in a particular experiment. So if I were doing a creep experiment, I might do a different setup than I would do for a strength experiment or a fracture experiment. So the whole idea of keeping things modular is that I can very easily have situations where I mount the indentation system to the chamber wall and the sample on the stage of the SEM or the FIB, or I can put everything on the stage in the FIB, or other sorts of ways of using the products, because they are very modular and can be strapped together in different ways to let you do different kinds of experiments. The whole idea of being able to watch these experiments is one of the big differences between the inSEM product and other nano indentation systems. You know, most of the time we're doing an experiment blind with nano indentation. In other words, we get the load displacement information associated with the experiment, but we don't actually see the experiment occur. So if certain events occur in the load displacement curve, we don't know what those events are. For instance, if the sample fractures or if the sample deforms in some way we don't expect it to. We don't know that in a standard nano indentation experiment because we can't actually see the experiment as it occurs because it is microscopic. But with the inSEM product, we can actually watch the whole thing happen and see how to identify events in the load displacement curve that match up with the physical processes going on. One of the nice features of the software that we have that runs this instrument lets you coordinate a recorded AVI file with the actual numerical data, the load displacement data, so that you can actually scan through the data after the experiment, and as you move a cursor, for instance, through the load displacement curve, the AVI file moves to the right place to show you what was going on at that point in the experiment. So it lets you really sort of look carefully at what happened after the fact and identify features in the load displacement curve and use those features to characterize the materials better.